write it. You can write it on the side because I'm looking at this function, and this is e to a function. So when I differentiate e to a function, I have to remember the formula, e to that function times the function prime. So that's why I'm kindly asking and begging everyone to redo the problems we do in class before you do anything else. So here it is, f prime of x, following the formula, I simply copy e to negative x squared plus 7x, and then multiply by the inner function prime. I know that this is the inner function. I bring 2 in front and subtract 1 from the power, and then 7x prime is
minus or plus 7.
That's it. This is done. You don't have to do anything else.
Oh, okay. I don't think I was trying to.
We are applying log.
I was asking. Does that make sense? I think I was trying to
we need to apply log when we solve an equation, and there are other methods and other situations in which we apply log. But here there is no need. Good. Next question. Anything else that you encountered in my lab math? Maybe something different that we did in class? Maybe you need help with anything? Yes, Manny, go ahead.
Yes, I have a question about that one.
Yes.
I know I should not simplify 2x plus 7, and I did on my work.
You cannot simplify. The only thing you can do, maybe you just put a negative in front, but there is nothing else you can do. So 2x minus 7 e to negative x squared plus 7x. You cannot do anything else.
Okay, I see. Yeah.
That's why we are here. That's why I'm begging you to ask questions, everyone. So I'm ready. Next question. Anything else?
Can we look at number 38 and 2.2?
38?
Yeah.
In 2.2. Very good. 38. 38.
Yeah, it's the same page.
Yes. So we have r of t, 5t minus 4, multiplied by e raised to negative 2t. So first we analyze the function, we see what we have, and then make a decision. So I see that this function is composed of a product of 2 functions, function 1 and function 2. On the side, I will write my formula. So 1 times 2 prime is 1 prime times 2 plus 1 times 2 prime. So then r prime of t will be, according to the formula, I have to differentiate this. And I get
5.
Excellent. Times the second function. That's what it says. And then plus. I copy the first function, which is this. And now I have to differentiate function 2. And I'm back here. How do I differentiate e to a function? E to a function prime is e to the function times the function prime. So e to the function, but times the function prime.
Would that be negative 2?
That's it. So now I have 2 terms. I will definitely factor out this, e to negative 2t, and let's see what happens. I have a 5. I have a negative 2 times 5t, and I have a negative 2 times negative 4. So my final form will be e to negative 2t, and this is negative 10t, and then plus 13. And I could factor out negative 1 and write 10t minus 13 e to negative 2t. And the reason is, why do I keep factoring out? As long as I see a negative leading coefficient, I will pull it out. You can say I'm allergic to negative leading coefficients. I am. I see a negative leading coefficient, I put it in front. Yes, Brendan, just 1 second. So if you leave it like this, you still get 100%. But this is very important for what follows in the next chapters. Yes, Brendan, go ahead. Sorry, my apologies.
Oh, never mind. I was just going to ask, because, like, on my answer, I put 13 minus 10t.
That's fine.
Like that.
That's fine.
That's an acceptable answer.
But I would like my students to get into the habit of presenting everything in descending order. If there is a negative leading coefficient, it doesn't belong there. It should be out. This is a habit, and I'm hoping that at least some of you will get into this habit. Till this point, even if you write 13 minus 10t, it's still 100%. However, all polynomials should be in descending order, and if there is a negative leading coefficient, out. Very good
And
question. Yes?
To find the second derivative, you just do the same rule, right?
Exactly. So
Okay.
this is a product, but that's why I clean it up. That's why I clean it up, because it's so much easier, especially if I have here like negative 10. I don't want to use large numbers, so I will leave negative 10 outside, and this will be my function 1, and this will be my function 2. Exactly.
Yeah, I messed up in simplifying.
No
I got a
worries.
similar answer, but
If
don't
it's
think I got it
this,
right,
you
but-
still get 100%. Very good questions. See, only if you try and you work, you do the work, then you will have questions, and then we have basis of discussion. That's why I want my students to do minimum of 60% so you can ask questions on the MyLab math, so you don't fall behind. Great questions. Anything else you would like to go back to? Is there anything else we need to look at? Any word problems from 2.1? Anything from MyLab math? Is it done?
I have one question.
Yes, I'm ready. Manny?
Can we review problem 82?
Yes.
But just part D with the limit.
Yes.
Please, and thank you.
Yes, of course. 82, that is from 2.2.
Yes.
82. From 2.1.
No, I think 82 is 2. Yeah, it was 2.1.
Okay. Yeah, I was there and I couldn't see it. Okay. So you're saying the one with the limit. So we have t of t, 22 plus 78 e to negative 0.041 t. And they're asking us to find the limit of t of t as time goes to infinity and explain what this number represents. Okay. So as you remember, when we are asked to find the limit of whatever, these are my props, of whatever, I have to plug this in. And you can say, well, how do you plug in infinity? Well, I have to think. It's more about thinking, not really plugging it in, right? So here's my function, 22 plus 78 e to negative 0.041 t. And then I would like to show you a little bit something with a calculator. Okay, so when I am asked to find this limit, first of all, I'm looking for t. Where is t? Not here, and not here. T is here. Okay, so when t approaches infinity, where does negative 0.041 t go?
Towards 20 degrees Celsius. Sorry, I looked at the graph. Like I graphed it. Never mind. I'm sorry.
When t approaches infinity, where does this piece go?
To 0.
So when I multiply a negative number by
Does it decrease?
when I
Because it's going to be a negative.
yes, and what? Just say it.
Infinity.
Of
negative?
course. So when I multiply infinity by whatever negative number, this approaches infinity. So this piece approaches negative infinity. Now I want to determine where this is going. So where is e to negative infinity going? Anyone? So this can be rewritten as 1 over e to infinity, or 1 over infinity. So where is this going then? I have $1, and I want to share it with, how many billions are we now? 10 billion, 11 billion on the globe. So when I knock on your door, how much could I give you from $1? Because I need to share it with everyone on the planet.
Is that the one that's going to 0?
Of course. Any tiny number over huge will always get closer and closer to 0. Okay, so then this gets to 0. And now let's continue. How much is 0 times 78?
0.
Good. How much is 0 plus 22?
22.
That's it. And you know, we say always that the limit of a function as x or t approaches infinity is a number. What do we know about that number?
Is it an asymptote?
Yes, absolutely. It's a horizontal asymptote. Here is another way of looking at this problem. So I just need to see my... Okay, so let me share my screen. Where are you guys? Okay, so in y equals... So we did a similar problem during the study group a few minutes ago. So this was 22 and this was 78. And this was, what was it? Negative 0.041. And the horizontal asymptote, 22. Okay, but now I just want to check. So I go to second and table, and I'm just going to punch in numbers. Bigger and bigger and bigger and bigger. So I'm going to say 100. Okay. Then I'm going to say 1,000. Oh, I'm going to say 2,000. Oh, I'm going to say 3,000. And I got my picture. So when t approaches infinity, where does the function go?
22.
That's it. And if I want to
So,
go ahead.
Question.
Yes.
I didn't really have my graphing calculator. I had to like type it in on an online one because I don't know where I put mine. But I saw like it looked like it was approaching 20, and is there going to be a question like this on the test? Because if there is any, make sure I do it different. But I put like I graphed the equation using the graphing calculator, and as the boiling water sat to cool longer, the closer the temperature approached to 20 degrees Celsius.
Okay, so
Would
you
that
can
be, like,
you can
completely
always look at the graph.
Okay.
And the most important thing is to analyze it.
Just double check the table.
To analyze it, yes, do the double check with the table, but analyze it very easily in few steps. So if t approaches infinity, this quantity approaches negative infinity. E to negative infinity has to approach 0. 0 times 78 is 0, plus 22 is 22. Very good. Other questions?
Can you leave this up for just like 15, 20
Absolutely.
seconds?
Anything else? Other questions for me? Is there anything else we need to look at? Anything from my lab math? I hope you made progress. I did not get the chance to look. I had grading to do today for a different class. So I'm hoping you keep up with me. Okay, so one more section from this chapter, and we are continuing with chapter 3. Can I continue now, Mallory? Do you still need it?
I keep unmuting it to stop talking and muting it to start talking. No, I was just copying the very bottom part of it now, so I'm good.
Okay, very good. So then we continue now with the last section, which is the derivative of natural log. Okay. So the natural log function, when we are asked to find its rate of change, we will get vector log of x prime is 1 over x. I should write times x prime. This is the correct way. But why I don't write x prime again? Anyone? How much is x prime?
1.
Thank you very much. Now, if we have natural log of a function prime, then this cannot disappear. Here it does because it's 1. But this cannot disappear. So this is 1 over the function and times the function prime. Okay? So that's all we needed to do in this section, and we just need to choose problems and practice. So this is section 2.3. So problems start on page 216. So let's choose. Feel free to choose if you feel like it. Okay, I will choose, then you will choose if you'd like. I'd like to start with problem 9 on 216. And I'm on page 3. Okay, so number 9. And we have natural log x over x to the 5th. So y equals natural log x over x to the 5th. And they're asking us to differentiate. Okay, so what do you notice here? Can anyone tell us, what do you notice? What type of function is it? Which rule do I need to apply?
You have to apply the quotient rule.
Excellent, brilliant, thank you. So I write it on the side if I need to. Okay, so it's 1 prime times 2 minus 1 times 2 prime over 2 squared. So I either write dy over dx or I write f prime of x. They mean the same thing. I immediately square the denominator. When I square this, what do I get? X to which power?
Uh, 25,
We're squaring it.
10.
That's it. Good. So now we differentiate the top function. We just learned that this is 1 over x times the second function, which is x to the 5th, minus. I copy the first function as is, and I multiply it by the derivative of this denominator. So can anyone give us the derivative of the denominator?
5x to the 4th.
Excellent. 5x to the 4th. Yes, I want to clean it up. What will I factor out in the numerator? Well, let's simplify this here. So this is x to the 4th first of all, minus 5x to the 4th natural log x over x to the 10th. Can you please tell me what will you factor out in the numerator?
I believe 5x to the 5th minus 5x to the 10th.
What will you factor out?
Would it be negative or x, maybe?
X to the
4th.
Very good. That's it. What do we have left in parentheses?
A negative natural log of x.
I have not reached the second term. I have to finish the first term first.
So that will be 5x.
I have not finished with the first term.
1.
Very good. Now I have minus. And now, yes. What is left from the second term?
Five x.
You mean natural log. That's it. But look what happens. That's why factoring is so important. 1 minus 5 natural log x divided by x to the 6th. Otherwise, you cannot simplify. And this is it. Okay, let's also look at, again, feel free to choose, 13. Let's stop for a moment. Any questions on this problem?